In this video, I'm going to discuss how we can calculate the primary voltage to the secondary voltage or vice versa. Now, before we get into that, we just need to quickly discuss that and remember that the primary is what is connected to the source of voltage and the secondary is what is connected to the load. I bring that up because oftentimes when we do examples for step-down transformers where we've got a higher voltage going to a lower voltage, that's not always the case. Sometimes you can actually have a lower voltage going to a higher voltage. So I just wanted to bring that to your attention. So let's get started here. We have a transformer. Again, it's going to be a step-down transformer in this example. The way we can tell that is we have 600 turns on the primary and we have 120 turns on the secondary. So what we need to do is figure out what our turns ratio is. The easiest way to do that is just take the higher number and divide it by the lower number. Always the higher number divided by the lower number. It doesn't matter if it's step up or step down. Say that this is the source of voltage. If I still had 120 turns to 600 turn transformer, being a step-up transformer, I would still go 600 divided by 120 to get what is called my turns ratio. So my turns ratio in this case is 600 divided by 120 will get me a turns ratio of 5 to 1. So again, just 600 divided by 120 gets me a turns ratio of 5 to 1. So now let's give ourselves a primary voltage and see what happens to our secondary. Now that I've given myself 1200 volts, I can take 1200 volts and divide that by 5 to get my secondary voltage. Now before we get into how to use the turns ratio for voltage, I'm going to go over another method that some like to use. Now you see here that I've got 1200 volts and I have 600 turns. That means that I have, if I go 1200 divided by 600, I have 2 volts per turn. For every turn in the primary winding, I have 2 volts in custody process. Now, the nice thing about it is with transformers is whatever my volts per turn are on my primary side will also be the volts per turn on the secondary side because they're sharing the same magnetic circuit. The lines of conductors are being cut over on this side, and so we're getting the same volts per turn on the secondary side. So 2 volts per turn that we calculated off the primary, 2 volts per turn times 120 turns will give me my secondary voltage, which is 240 volts. So that's the volts per turn method. Now myself, I find that can get a little confusing because we won't always be given the turns. So we'll generally be given voltage or current or VA or all of those. So using the volts per turn method might not always work for us. So that's where we come into the turns ratio using the 5 to 1 ratio. Again, I start with 1200 volts and I'm going to divide that by 5 and that will get me my secondary voltage, which works out to be the same as what we did when we worked out the volts per turn, 240 volts. So again, you see the turns, 600 divided by 120, you get 5 to 1. 1200 divided by 5 gets 240. If I want to work backwards, say I didn't have this, but I know this is 240, I go 240 times 5 to get 1200 volts. Practically, when you're dealing with transformers, you won't be given the number of turns. You can still use what's called the turns ratio though, so you can still go 1200 volts divided by 240 volts to get the turns ratio of 5. And that becomes important when we're trying to deal with other calculations such as trying to figure out what the current is, which we'll cover in another video.